Hello everyone and a warm welcome to our webinar Lawyers in Orbit, Azerbaijan Türkiye team up for astronaut health, NeuroLaw, space law and space policy beyond Earth. Please note that this webinar is being recorded. I would like to thank each of you joining us, researchers, students, legal professionals and space enthusiasts from across the globe. It's inspiring to see so many bright minds gathering here to explore one of the most exciting frontiers of our time. My name is Maral Erol, and I'm delighted to welcome you all as the speaker and host from Türkiye. I'm an attorney at law, and my professional practice includes several areas, one of which is aerospace law. It's a true pleasure to be part of this fascinating discussion today. I'm also honored to be joined my distinguished colleague, Rafizade Najiba, a lawyer from Azerbaijan, who brings valuable insights and expertise to our discussion. Together, we will explore topics such as astronaut neurobiology, NeuroLaw, space law, and space policy. This event is not just about science or law, it's about preparing for a shared future where both must work together to protect and empower those who venture beyond our planet. Welcome aboard and thank you for being part of this journey. Dear Najiba, I would like to invite you to the stage. The stage is yours, please. Let's get started.
Thank you very much. I'm really pleased to be part of this event and thank you very much for your kind words and your invitation. I'm really happy to see you all. I know that you all, each one of you is a professional in your own areas. And welcome to Lawyers in Orbit. Before starting, I want to apologize because I have some technical issues with sharing my screen, but after the webinar, I will send you all my presentation in PDF format. Well, let's start. I want that you all imagine this scenario. An Azerbaijan engineers and the Turkish neuroscientists are now and we're all on this story. Thank you and safe travels, whether Earthside or otherwise. Thank you very much.
Thank you very much, dear Najiba, for this insightful talk. We came to my part. I don't have much time, that's why it's going to be very, very short. Let me...
I'm so sorry. Yes, I'm so sorry.
Oh no, it's not your fault. It's not your fault. It's meant to be like this because, you know, it's a complimentary webinar. And now I'm going to share my screen. Yeah. And we are going to start. Please tell me if you see my screen.
Yes.
Okay, so welcome again. In this webinar, I'm going to talk about several key issues related to astronaut selection and health and data governance. My agenda as follow. First, I'm going to talk about the balancing technical skills and psychological resilience, how to become an astronaut. Then I'm going to talk about responsibility for astronauts' neurological brain changes. Then I'm going to talk about legal and ethical frameworks and share some recommendation to space agencies on collecting and monitoring astronauts' personal data. So let's start with first chapter, becoming an astronaut, balancing technical skills and psychological resilience. While the career of an astronaut may seem glamorous with the beauty of the stars just within reach, it is actually one of the most competitive and demanding paths in the world. Becoming an astronaut requires advanced scientific education, technical expertise, and exceptional physical and psychological resilience. Unlike professions like well-established national licensing systems, astronautics has no global or universal authority. Each space agencies, such as the NASA, ESA, or TUA, sets its own selection criteria, medical standards, and rigorous training requirements. So now let's take a look at the six-step guide outlining the requirements to become an astronaut. Here I shared some recommendation if someone wants to become an astronaut. I'm going to really fast on this and going to second chapter. But before I start my second chapter, I want to say that historically, psychological resilience has always been a key focus. During the space race, the Soviet Union was in intense competition with the United States. As we all know, Soviet cosmonauts were selected and trained under extremely strict conditions. I don't know that I not think that something changed these days. It's still very hard. In my opinion, tests were designed to push human limits, essentially searching for superhumans, like if we can say it like this. One of the most demanding assessment was the isolation test, in which a cosmonaut had to remain completely alone in a sealed chamber for 1 week, for example. This is an example from historical Gagarin's tests. So, and among the neurobiological changes in the brain, it's very important to consider that microgravity effect. So we have a lot of aspects here, but I'm going to really fast. I think that in the next webinars we can talk about deeply in these topics. So understanding responsibility for astronauts' neurological brain changes. There is a lot of definitions about this. For example, Roberts and others define neurobiological brain changes in astronauts as measurable structural adaptations in the brain resulting from microgravity and other spaceflight stressors. In the literature, additional neurobiological changes observed in astronauts include alterations in white matter, microstructure, and structural connectivity, and fluid shift effects in the brain, all which are linked to the central nervous system's adaptation to spaceflight conditions. So, the liability. Today, international space law instruments establish general duties related to astronaut safety and assistance. Let's start with Outer Space Treaty. It drafted before modern neuroscience. Article 5 of this treaty, in my opinion, can be interpreted to cover neurobiological risks in spaceflight. While the obligation to report phenomena, according to this article, may include newly observed brain changes as well. Designation astronauts as envoys of mankind reinforces the need to protect their physical and cognitive integrity, indicating that Article 5's protections are adaptable to modern understanding of astronauts' neurological health. So when we move, also we see that in Outer Space Treaty, Article 6 defines that parties bear international responsible for national activities in outer space, including the moon and other celestial bodies, if relevant medical issues are not properly addressed. For example, if an astronaut with inadequately assessed health is sent on space mission and as a result performs actions that could cause harm, the state can be held internationally responsible for its national activities. This highlights the critical importance of true medical monitoring, assessment, and treatment of astronauts to ensure both mission safety and compliance with international obligation. The rescue agreement future requires states to provide all possible assistance to astronauts in distress, establishing a broad responsibility for their welfare. Although the agreement does not explicitly mention neurobiological monitoring, its humanitarian mandate can reasonably be interpreted to include the obligations to address neurobiological risks and impairments encountered during space missions. The Liability Convention provides a framework for state responsibility in event of damage arising from space activities. Article 1 defines key terms such as damage, launching state. Article 2 of this convention, a launching state is held absolutely liable for any damages caused by its space objects on Earth. surface or aircraft in flight regardless of fall. This strict liability means that victims of space-related accidents can seek compensation without proving negligence. Consequently, if neurobiological brain changes in astronauts impair their ability to control a spacecraft, resulting in the space object causing damage, the launching state will still be fully liable. This interpretation underscores the critical importance of monitoring and managing astronauts' neurological health, as impairments affecting cognitive or motor functions could lead to accidents with significant legal safety implications. Convention on registration is defined. This registration facilitates the recognition of which state is responsible and therefore liable under the liability convention if some damages will happen. The Moon Agreement established several obligations relevant astronauts' welfare that can be interpreted to include neurobiological consideration. Article 10 mandates that the states parties adopt all practicable measures to safeguard the life and health of persons on the moon, to provide shelter to those in distress, effectively extending humanitarian protection to astronauts. Article 5 requires states to inform the United Nations and scientific community of any phenomenon. Furthermore, Article 5 requires states to inform which can responsibly be interpreted to include discoveries about neurobiological risk associated with lunar missions. However, the practical implementation of health surveillance is primarily governed by national legislation, space agency policies, and mission-specific medical program. As space missions extend beyond low Earth orbit, it becomes increasingly important to examine how legal responsibility, agency policies, and medical monitoring interest to safeguard astronauts' neural health. For instance, NASA's efforts about astronaut occupational health project, lifetime surveillance of astronaut health, Threat Astronauts Act. I'm going to talk about them in details in the next webinar. And for example, ESA has a crew medical support office responsible to monitoring astronauts' health. Responsibility for astronauts' health, including potential neurobiological changes from spaceflight, is distributed across multiple levels. Under international law, the launching state holds ultimate responsibility for authorizing and supervising national space activities, whether governmental or non-governmental, as established in Outer Space Treaty. Operational responsibility is typically delegated to the National Space Agency, which implements monitoring, safety, and post-mission medical protocols in accordance with national legislation and agency policy. While astronauts provide informed consent for inherent mission risk, international treaties such as Rescue Agreement emphasizes the protection of astronauts and their safe return. Now we are moving to our next chapter, Managing Astronauts' Data, Legal and Ethical Frameworks. Following discussion on responsibility for astronauts' neurobiological changes, it is important to recognize that space agencies systematically collect sensitive medical and physiological data to safeguard their personnel. To fulfill this duty of care, agencies continuously monitor a range of health metrics, including cognitive and neurological assessment, in order to identify potential risks and intervene proactively. Advances in health monitoring technologies such as real-time psychological tracking are increasingly employed to enhance astronaut safety. The collection and use of this data are conducted in accordance with applicable privacy regulations and ethical standards, ensuring both the protection of personal and integrity of research initiatives. Sorry, we have a problem. Um, Sorry, I guess we dissolved the problem. So now let's continue. So I said that establish an incident and breach response framework. What does it mean? Create procedures for the dedication and investigation, reporting and recovery in the case of any incident happened. Regulate data transfers and international cooperation. Ensure cross-border data exchanges follow treaties, agreements, and adequate protection standards. Conduct oversight, training, and audits. Maintain continuous monitoring and compliance updates. What does it mean? Revive documentation annually, update system after mission change, and monitor emerging legal requirements. Thank you very much for joining this session. So we end our webinar for today. See you in our next webinars, and we are happy to answer all your questions. Let me check the chat.